To customize the text files and Python code from the I2GROW GitHub repository to be specific to your system, you must go through the following steps. First, we will set up the configuration file to have the necessary information from your system so that ROS2 can communicate with the various sensors and components of your system. Then we will edit a text file that will tell the graphical user interface that ROS will initialize when it runs the system what order you want to display your plant images in. Then we will insert light intensity data into the Python code. Then we will tell the Python code where the coordinates of each of your plants are. And lastly, we will edit the exposure setting of your depth camera so that the images can be viewed. The configuration file will require the following information. This file can be found in your File Explorer under ROS FarmBot data as config.txt. The first two lines of this file will be your username and password respectively for the FarmBot software. The third line will be the sequence ID of the raster sequence that you set up in the FarmBot software to go through and take images of your plants. You can find this sequence in the FarmBot software. Go to the software and click on Settings. Then search for View Celery script and turn that setting on. Then, when you go to your sequences, you'll be able to see the code for each sequence step. Make a sequence that has one step, which is your raster sequence. By clicking on that sequence, you can then see the ID of your raster sequence. Copy and paste this ID in the third line of the configuration file. Next, we need to tell ROS2 the device path of our webcam. To find this, open a terminal by clicking Ctrl-Alt-T and paste this line of code into the terminal. It should return a list of camera objects that are plugged into your PC, for example through a USB. If you have your depth camera plugged in already as well, that should show up too. If you aren't sure which device path matches your webcam, you can copy and paste this list into AI such as ChatGPT or Copilot and give it information about your webcam, and it will tell you which device path is corresponding to your webcam. Now, paste that device path into the fourth line of your configuration file. To use the environmental sensor, we will connect it to our computer through Bluetooth. Go back to your terminal and type the following command to initialize Bluetooth. Then type scan on to start scanning for nearby Bluetooth devices. A list of the nearby devices should show up, including your environmental sensor. You can again copy and paste this list into AI to find the exact MAC address of the sensor that you want to connect to. Then add this MAC address into the fifth line of your configuration file. The last line of your configuration file will contain the file path for a file that you will download from the GitHub repository for I2GROW. Download the file and then record the file path in the last line of your configuration file. You can find the file path by looking into your download folder. Now your configuration file is complete. Make sure to save the file before closing. Before you close your terminal, also make sure to type scan off and turn off Bluetooth scanning. You can now safely close your terminal. We will now tell ROS in what order and where we want the photos of our plants to pop up on the graphical user interface. You should have a document called UI Order.txt in your ROS FarmBot data folder. The first line of this text file should be the number of rows and columns of plants that you have. Then list the coordinates of each plant in the order that you take pictures of them. So the first row that you take pictures of should all come first, and then the second row, and so on. You will also need a text file in the ROS FarmBot data folder called coords.txt that lists all of the coordinates of the locations of your plants in this same order that the pictures are taken of them. If you have a PAR light sensor, you can skip this next step, but if not, you will need to edit the PAR sampled grid file to also have the coordinate locations of each of your points, and a third piece of data that is the light intensity in micromole at each of those points. The order of the coordinates should be the same as in the previous two files. Now we will add the coordinate locations to the Python code. Go to the ROS2 folder, src, and then the ROS FarmBot folder. Click on the central I2GROW automation Python file and find where locks or locations are defined. Edit this to be the same as the coordinates for your plants. Leave the final coordinate as 100,000, 100,000. Now in scripts, find the uiprinting.py file and add the locations for locks again. Lastly, to adjust the exposure of the RealSense depth camera, open a terminal and type RealSense-Viewer to open the Intel RealSense software. To view what the current exposure setting is, click the drop-down menu under RGB Camera and the drop-down under Controls to view what the exposure is set to. Now, in the ROS FarmBot folder under Scripts, find the RGBD frame grab Python file and add this snippet of code. You will add it around line 65. Enter the exposure value you just saw in the RealSense viewer and test taking images to see if the exposure is set correctly. If it is too bright, make the exposure a slightly lower, and if it is too dark, make the exposure higher. Make sure to save all the files you have made changes to after editing them. Also, before running the whole program, make sure to rebuild your system by running the following commands in the terminal. Now, you're ready to run the overall program by running the following commands. A window should pop up, such as this. Your camera will now move to its home position and then move to each plant location as you have programmed to take images. The images will pop up in the order that you have also programmed. Congratulations for setting up the system.